Hello, ladies and gentlemen. We are doing lesson 6 for Algebra Extended, Unit 2, lesson 6. So we're going to be solving linear inequalities, including word problems. So when you met me last, we did some inequalities, some basic ones, just looking at how they are, like greater than, less than, greater than, equal to, or less than, equal to, right? So all those symbols from lesson 5. Now we're going to get into actually doing some solving with them. Okay, first there's something called the golden rule of solving inequalities. And you might remember this from earlier years. So when you multiply or divide with negatives, we always flip the inequality. Okay, so you'll see it actually in the problems here. Instead of me going through, we'll just start a problem and I'll show you how it works. All right, so you're gonna get an inequality like number 1, and you're gonna do just as if you had an equation. You're gonna get the y's to one side and the constants to the other, and then you're going to solve for y or solve for x or whatever the variable is, and then you're going to graph on a number line, okay? And I do want you to, depending on what it is, it's interval notation, or set, like if it doesn't say interval notation, then you just leave it as y is greater than or less than or whatever. But these are going to be mostly interval notation because we want you to practice that, okay? So we'll go through that too, because I know that was rather quick in class. So I want to make sure that you get the hang of it in this video. So first I'm going to start by subtracting 7y to bring all the y's to one side. And then I'm going to subtract the 4, and I've got y is less than negative 6, okay? Then I'm going to put negative 6, one lower number, one higher number. I'm going to put an open circle at negative 6 because it doesn't include negative 6. But remember, this is y is less than negative 6, which means y, the alligator eats that bigger number. The bigger number is negative 6. So y is anything that's smaller than that. So that is negative 7, negative 8, and so on. So it goes in that direction. For an interval, remember intervals are like the infinities with the brackets versus the parentheses, all that good stuff. So you, with infinities or negative infinities, you always put parentheses around them. If it includes a number, it's a bracket. If it doesn't include a number, it's a parenthesis. So we start by looking at this and go, all right, negative infinity, right? Because it's start looking at the left, it goes negative forever. So we go left to right when we read it. We go negative infinity, so that's always the smallest number. Always wrap infinities with parentheses. And then what's the number it stops at? It stops at negative 6. And because it doesn't include negative 6, we always do a parenthesis. If it included, it would be a bracket. Okay, so that's your first one. Second one, we're going to solve just as if it were an equation. Forget it's an inequality for a second. Let's just look at the left side and go, all right, I would distribute. So I have a negative 6x minus 12 is greater than or equal to 0. Okay, get the x's by themselves. So I'm going to add 12. So it's negative 6x is greater than or equal to 12. Okay, then I look at it and say, all right, I got to get x by itself. It's being multiplied by negative 6, so undo by division. But here's your golden rule for solving inequalities. If you divide by a negative, okay, so it says if when you multiply or divide with negatives, right, or probably let's change this by to with. Multiply or divide by a negative, because it's the division, when you're looking at division, it's when you divide by a negative, and the negative's got to be on the bottom. So if that like was a negative 12, In a positive 6, we wouldn't change the sign, but because you're dividing by a negative, right, where the negative is on the denominator, then you actually have to flip the inequality. So we cancel that out, and we say now x is going to be less than or equal to 12 divided by negative 6 is negative 2. So see that inequality? It flipped, right? Flipped over. Went from a greater than to a less than. So then we're going to do negative 2, negative 3, negative 1. Close circle at negative 2, right? X is less than or equal to. So that means x is going to go lower, right? It's going to go lower than. Any number smaller than negative 2. Okay, and then we're going to do that interval notation again. So what is it doing? Is it going left forever? Again, reading the smaller numbers, it's going left forever. And it stops at negative 2. Now the big piece here is it includes negative 2, right? Remember this inclusion, which means it was a closed circle. So that means that then this must be a bracket. Okay, that must be a bracket. Okay, try 4. So 4, I'm sorry, try 3. We're going to skip 4. My bad. I'm jumping ahead. We're going to skip 4, actually. We're going to do 3. So I'm going to look at 3, and I'm going to go, all right, I got distribution on both sides. I'm going to distribute the 4 on the left side, so it'll be 4x minus 12. And then I'm going to distribute the 2, 2x minus 4. Okay. And I'm going to get the x's to one side. So I'm going to minus the 2x. And I've got 2x minus 12. I'm going to add the 12. And I've got 2x is greater than or equal to 8. And then I'm going to divide by 2. Not dividing by a negative, so don't flip the inequality. It's just x is greater than or equal to 4. All right, so now close circle because it includes, right? Because it says equal to. It includes. And I'm going to arrow anything greater than 4. X is greater than or equal to 4. Okay, for the interval, start with the lowest number. The very lowest number in this case is 4. It includes 4, so it's a bracket. Okay, we're going to put a comma, and then it goes to infinity. So we're going to put infinity. And always wrap an infinity with a parenthesis. And that's it. We're going to skip 4, like I said. All right, guys, so now we're going to go to the back page, and we're going to do just a couple word problems. I'm only going to have you do question 5 and 7 today, okay? So we could talk about words or phrases that will indicate the following. So like, I'm not going to do anything fancy with this one. We're going to say that anytime you hear the less than, it's that one, less or equal to, right? Or at most means it would be a less than or equal to. If it's a greater than, oh geez, Mrs. Reese can't spell. It's a greater than, never said I was an English teacher. Greater than, or if it's a greater than or equal to, we know greater than, equal to, or at least. When you hear the word at the very least, that means that it's going to be that number or greater than that number, right? So there's a couple of key words here. Okay, I want you to take a minute and I want you to read number 5. I'm not reading it for you. Take a minute. Okay, so just like any word problem, you better define the variable. So what's the minimum amount of whole hours she'll need to babysit? So H, I used H, equal hours to babysit. Now she got $8 from her dad. $8 it contributes to that graphing calculator. It's a $100 graphing calculator, okay? So it's $8. Plus, every time she babysits, she gets $5. So we don't know how many hours she's going to babysit. So we're going to say that I've got to have that 5 times H. Now, she needs $100 to buy a graphing calculator. So she could earn more than 100, right? So at the very least, it should be, this should be greater than or equal to $100. So this has got to be at least greater than, could be equal to $100. So see where I've got that inequality that comes into play here? All right, then we're going to solve. So now we're going to say minus 8 is 92 divided by 5. And now when you do H is greater than or equal to, when you do 92 divided by 5, you get 18.4. So remember the question emphasized what is the minimum amount of whole hours that she needs to babysit. So she can't babysit for just like 0.4 of an hour and say, all right, I'm done, I got my $100. She needs whole hours. Now remember, this is H, the hours, is greater than or equal to, sorry, I didn't put the equal to sign, greater than or equal to 18.4. So if I want whole hours, it can't be 18 hours. It's got to go up to 19 hours. So the minimum hours would be 19 to earn the at least $100. Okay, so she needs 19 hours to babysit in order to get that $100. So you got to round it up in this case. All right, 7, read it, and I want you to draw a rectangle, and I want you to give me some variables for this. Okay, take a minute and read it. Now, I've said this to you guys many times. When it says length, not many times, a couple times. When length of a rectangle is compared to the width, you have to say that the width is what you start. So let W equal the width. Whatever they say second is what you define first. Okay, whatever they say second, so they said length and they compared to width. Width has to be defined first. Length of the rectangle is 5 times the width. So 5W is equal to the length. Length, width, and here's a key here. Perimeter, the most the perimeter can be is 104. So it can't go over 104. It's got to be 104 or less. Okay? So how do we do perimeter? Remember, perimeter is where you add all the sides. So I've got 2 of these. I got 2 5Ws. I've got 2 Ws. And they're saying that the most it can be is 104. So this perimeter has got to be less than or equal to 104. Can't go above 104, right? So 104 is like my maximum amount here. Okay, so I'm going to multiply these. I'm going to combine, and I'm going to divide. And I got 8.6 repeating. Now it says find, this is where you got to go back and read the details of the question. It says find the greatest possible integer. All right, so the integer is a whole number, and the greatest one, okay? Now, sometimes I think it's even helpful to put it on a number line so you can think about integers. So 8.6 is between 9 and 8. Those are integers. Remember, integers are positive or negative whole numbers. W is got to be equal to that or less. So the integer, the first integer it can be is 8. So the greatest possible integer dimensions. So W is 8. So that means the width is 8 meters. Because when they ask for dimensions, they want the width and they want the length. They want the dimensions of the whole thing. So you got to also tell me the length. And then the length, remember the length is 5 times that. So you would come up here and do 5 times 8. So the length is 40 meters. So this would be 40, 40, 8, and 8. And even if you wanted to double check, like add them all up, just make sure that it's not over 104. That's would be important to do, right? And when you add all those up, you can do that, okay? All right, so we got one more video. One more video tomorrow for you guys, which is compound inequalities, and then we're done with this unit. This is it. So, and then you've got a checkpoint that you're gonna do a mixed review and checkpoint. So we'll get on that, okay? So make sure you're following your agenda, get all your notes down, make sure you do your homework for this, okay? And we'll see you soon. You know where to find me if you need it.